Hi, my name is Jess Lane, and we've been talking about proportional relationships. So, if you don't know about proportional relationships, please go and watch that video. And so, what we're going to do here is we're going to determine if this table is proportional or not by using a graph. So, to know if something's proportional, it's a graph, here's a big hint. So when you graph something, if it's proportional, it will go through that point 0, 0. If it does not go through the point 0, 0, it might be linear and have a constant rate of change, but it will not be proportional. It has to go through that point 0, 0. So let's graph these. So here's our x values and our y values. So here's our first point, 2, 4. So I'm going to graph that, 2, 4. And graph the next one, 3, 6. The next one, 4, 8. So if you notice we're graphing, it's going up 2 over 1, up 2 over 1. So I'm going to continue to graph to see if it's proportional. So up 2 over 1, I can do the opposite here, down 2 over 1. Down 2 over 1, you notice that it hits that origin, 0, 0. So yes, this is proportional, okay, because it hits the origin 0, 0. Now the constant of proportionality, once we determine if it's proportional, if it goes through that origin of 0, 0, the constant of proportionality is just the slope. We know how to find slope. We have done it. It's our change in y's over our change in x's. If you need to review, go watch the video on slope. So I'm going to pick 2 points. Our change in y's over our change in x's. I'm going to pick the point 2, 4 and the point 3, 6. And my change in y's, 6 minus 4 is 2. So these are my y's, 6 minus 4. And then my change in x's, 3 minus 2 is 1. So my constant of proportionality is 2 over 1, which we can just simply say 2 because anything divided by 1 is just itself. So its constant of proportionality is 2. Now to write the equation, we need to know 2 things. Again, this is written in y equals mx plus b form. If you don't know slope-intercept form, go and watch that video, okay? Slope-intercept form, we know this is the slope, which is also called the constant of proportionality. We know our slope is 2, so 2 is going to go in here. And then our y-intercept. Well, with proportional tables, we know our y-intercept is always going to be 0. Our b will always be 0, our y-intercept, because it hits the y-axis at 0, 0. And so we know we won't, so we can write it. So our equation, y equals our slope is 2, our constant of proportionality is 2x, and then plus 0. What's funny is we don't ever have to write this because when we add 0 to anything, it doesn't change its value. So our equation for proportional problems will never have the y-intercept written because the y-intercept is always 0. So our equation is just y equals 2x, which means that the slope is 2. Let's do another one. Okay, let's do another one here. Let's see if it's proportional first. So we're going to graph it. Remember, it has to go through 0, 0 for it to be proportional. Let's just graph what we have, 1, 6. So I'm just using my table here, 1, 6, 2, 8. I'll graph a few. I don't have to graph all of them. 3, 10. And now I can kind of see what it's doing. It's going up 2 and over 1. So I'm going to continue that down here. So up 2 over 1, you can do the opposite, down 2 over 1. Oh, it hits the y-axis at 4 and not 0. So this one is not proportional. So it's not going to have a constant of proportionality. It will have a slope, but not a constant of proportionality. So since it's not proportional, we don't need to write the equation. And yeah, so again, it doesn't hit 0, 0, so it's not proportional. Thank you for watching.